Hello everybody, welcome to Test 3 Review in Calculus. As always, you see the topics of the question on the top and the formula will be on that side. Right, let's go straight to it. First, we have a work problem in optimization. Let's highlight a few important things. First, we have the box for shipping. We want to have the largest volume. And this box have a square end, so that is important. If it is a square end, this is x, the other one will also be x, and let this be the length y, and the volume is going to be equal to length times width times height. Be equal to y times x, or will be x squared y. That is the volume. And we need to maximize this function. Right. One thing we haven't used in the problem is that the girth, the parameters of the base, and the length. All of them add up, do not exceed 120. So we're going to have x. The girth will be 4x and y. So for that statement, we have 4x plus y less than equal to 120. But we'll make that equal to 120 because here we want to have the maximum volume. So we choose 120 so to have maximum volume. If it's less than 120, we can always make it a little bit bigger. So that will be, it will have the bigger volume. Right, so we have this. For x plus y equal to 120, we can solve for y is 120 minus x for x. And substitute that in for this y. So we will have the volume is x squared 120 minus 4x or 120x minus 120x squared minus 4x cubed. Right, so that is the function that we're trying to find the maximum. Right, I'll just need to say what will be the dimension. First, x has to be positive. Any measurement, we still need to have that. So let's focus on we have x is going to be greater than or equal to 0. So that's the first condition for sure. Second, y is also has to be positive. So we have y equal to 120 minus 4x have to be greater than or equal to 0. Move the 4x over. We have 4x will have be less than 120. So x is less than or equal to 30. Right, so that we have those two conditions. So put all of this together, we have the problem is this: maximize the function and x will be between greater than or equal to 0 and less than or equal to 30. So we say x in from 0 to 30. Right. The math is easy. So let me zoom in and now we focus on solving that. So we will have two steps when we do that. The first step is find the critical point in 0 and 30. So we check derivative will be 240 x squared could be just x 240x and minus 12 x squared. Right. So next, let derivative equal to 0 and derivative does not exist. Here we can factor out 12x and we have 20 minus x equal to 0. So we're going to have 0 and 20. Now let's just focus on the problem. Right. Next, derivative does not exist. We have nothing. Next, those points belong to 0 and 30, so that's good. So we have 0 between 0 and 30, so that's one good, and 20 is between 0 and 30, that also good. The second step is we just set up a table. Here we just use the original function. Always use original function in absolute max and min problem. In the table, I mean. We have 0 and 30, and in between there is 20. Right? And we just need to evaluate this. I'm going to use a calculator for this one. Just put that here for a moment. Right. So I'm going to use the list, hit stat, and enter. The list will be 0, 20, and 30. After that, highlight L2 and enter this function. 120 L1 square minus 4 L1 cube. Hit enter, and we have 0, 16,000 and 0. Obviously here that will be the max, the absolute max. So we have x is equal to 20, so max volume occurred x equal to 20. We just say max at x equal to 20, and then we go back up there. Let me zoom out. Right. We have y equal to 120 minus 4x. (120 minus 4 times 20), so that will be 40. So the dimension we have here is 20 by 20 by 40. So we say 20 by 20 by 40 is the dimension of the maximum volume. inches is a unit. So 20 inch by 20 inch by 20 inch box. Right, so that will be the first one. So pretty much we try to write the function in terms of one variable and with the domain of the problem, and after that critical point along with the boundaries we check all of them. The biggest one is the max, and this one did not ask for the mean, so that's what we have. Next, a piece of molding of 188 centimeter long. First let me try to see what this problem is about. We have 188 to be cut to form a rectangular piece. So let's cut this in half, and after that one long one. So we have an x, a y, a x, and a y. From there we can form a picture frame, x, x, y, y, and this is going to be 188 centimeter long, so that will be like that. Right, so pretty much what we do is we first from here we have 2x plus 2y is equal to 188, and then what we try to find is the one with the largest area, and area is equal to for this rectangle, which is x times y. Here 2x plus 2y is 188. Divide everything by 2 because all of them are even. We have x plus y equal to 94. So y equal to 94 minus x. And I can substitute that. In there. So we have a is equal to x, 94 minus x, multiplied out 94x minus x squared. Right, so we have the function to be maximized. So just say maximize the area of 94x minus x squared. Right, next, the boundary. Let's see what do we have. As always, any measurement must be greater than or equal to 0. So we have x greater than or equal to 0. That part easy. And y also need to be greater than 0. So if you solve for y, we have plus x on both sides, 94 greater than or equal to x. So x is between x is greater than or equal to 0 or less than or equal to 94. We say from 0 to 94. Or we can also write like this. And this is our problem. The math of this is pretty simple. Check derivative, find critical point, and then put in the table. Check with the original function, and that's pretty much it. So I'm not going to finish that problem. Right. Next we go to linear approximation. Linear approximation, pretty much we'll see the highlighted formula on that side. So we write the approximate of the function equal to the function at a plus derivative x minus a. This of course is also the equation of a tangent line, but this is a review. We're not going to go much to see where they're from. Right, so first let's do this problem. So first, when we look at the problem, if we see any number in the problem, that will be x. So x is 144. So if we let x be 145, sorry, that number in the problem. Now if we let x equal 145, then we have square root of x, and we let that function be f of x. Right, so whatever number in the problem will be x. Replace that back, we have square root of x, which is a function. Next, we're going to choose a number that is very close to this. So I will choose a. That number is going to be a. Whatever a is has to be close to this, and the square root comes out nice and even. So I would choose 144 because square 144 is 12. That is exact values, so it's good. So we have a, x, and f of x. Let's write the formula out again. We have the function approximately equal to the function at a and the derivative at a, x minus a. Right. Now we need to determine these components, the function and derivative. Right. We know the function is square root of x. So if we put 144 into it, when x equal to a equal to 144, the function at 144, square of 144 is 12. Next, we take derivative. The function square root of x, we can also write 1/2 x, x to the 1/2, and derivative will be 1/2 x to the negative 1/2. Now we're going to put in 144. Derivative of 144. Right, bring back the calculator. One half times 144 to the negative 1/2, and we can change this to fraction, 1/24. Right, so we need the values of the function and the derivative. So we're going to put here the function and the derivative. X is 145 minus a, 144. So pretty much 12 plus 1/24. So we have 1/24, just need to add 12 to it. So we have that fraction. In the spirit of approximation, we will write 289/24 or 12.0417. Right. So that is the approximation. Right. Next one we'll do similar. So similarly, formula is still the same. Right, so first, the only number we have is negative 0.01, so that would be x. If that is x, then we have sine of x is the function. Right, and then we choose. Whatever we choose will be have to be close to this number, and the sign values is nice and even. So that one obvious. We're going to choose 0 because sine of 0 is 0. Right. So we're going to have the function approximately equal to the y values or the function values and the derivative value times x minus a. Right. The function is sine x at x equal to 0. The function at 0 is sine of 0 is 0. Derivative is cosine x. Derivative of sine is cosine, and at x equal to 0, derivative of 0 is cosine of 0 is 1. So we have 0 plus 1. X is negative 0.01. A is 0. So do that, we will have negative 0.01. Right. These two problems. Let me update the list. Next, we have differential. So pretty much the derivative. So we just take derivative. Right. This we use the chain rule. So first we have a parenthesis here. Derivative, we will write derivative of sine is cosine of the parentheses and times derivative of the parentheses. So that's the backbone of the chain rule. Doesn't matter what it is inside, just take derivative and multiply by derivative of the inside. So now we have 3x squared and then 3x squared is the parentheses. Now we just take derivative of 3x squared will be 6x. Will be equal to 6x cosine of 3x squared. Right, that is derivative. We can be written in different form like dy over dx. So we just need to move the dx to that side and that's it. Right, so just take derivative and move the dx over. This one happened to be derivative using the chain rule, so we have to use the chain rule, and that's about that. Right, next, find a spherical balloon is inflated the change in volume. So want the change in volume if the radius increase from 5.2 to 5.3. So first we have the volume for the pi r cubed. If we take derivative, we have dv over dr equal to 4 over 3 pi. Derivative of r cubed will be 3r squared. Those two cancel out. 4 pi r squared. So dv 4 pi r squared dr. So that is the differential. If we approximate the change in dy, we will have dv approximately equal to 4 pi r delta r. Right? So that is the approximate change. In that case, we need to know what is r and what is delta r. Now we go back to the problem. We have the radius, which is r, is changing from 5.2 to 5.3. So initially, r is equal to 5.2, the initial values. And then the delta r is the final minus initial. 5.3 minus 5.2 equals 0.1. So we have r is 5.2 centimeter and dr is 0.1 centimeter. So pretty much we have 4 pi 5.2. I forgot the square here. And delta r 0.1. Yeah, multiply all of that. We should get the answer. Right. So what we just have is the differential, and here we use pretty much the same thing. But if we convert that to the delta, meaning we approximate the change. So those differential and approximate the change in y, those are pretty much the same idea. So what we did was 5 is here and 6 is here. Right. Next, mean value theorem. Find the values of c, that satisfy the condition for that. So pretty much the condition of the mean value theorem says that this is the slope of the secant line that go to the end point. And this is the slope of the tangent line. So try to sketch real quick here. If we have A and B, the end point, doesn't matter what the function look like. First we have the secant line connect A, the point when x equal to A and x equal to B. And after that, there will be a point on the function where is the tangent line there is parallel to the secant line. So pretty much we just find these two first. First the secant line. I will take find the secant line from 1 to 2. Alright. So we take the derivative, I'm sorry, f of 2 minus f of 1 over 2 minus 1, right? So we're going to have put 2 in this, so square 3 times 2 plus 4 minus, now where we put 1 into x. So now we just do that. 4, 4, 6, 4, that's 14. 4, 14. And that will be 1, 3, and 4, that will be 8. Pretty much will be 6. Divide by 1, of course. It's just itself. Right, and then the tangent line. We do not know where the point C at. So C is the point that is unknown in the middle. So we take the derivative. Give us 2x plus 3. And then by that the main theorem, those still have to be equal. So we make 2x plus 3 equal to 6. Move the 3 over, we have 2x equal to 3 and x equal to 3 half. And indeed, the point 3 half is between, why do I have two b's? This is a, sorry. The point 3 half is between 1 and 2. So, again, the secant line go through A, the point x equal to A and x equal to B will be parallel to the tangent line. We just don't know where the point at, but the point must be in between the endpoints. As long as the function is continuous and differentiable on the open interval in between. Right, so pretty much that. Slope of the secant line equal to slope of the tangent line. And that is that. All right. Next, find the limit. Here we might use the Hopper rule a lot. Right, we look at the fields of this problem. Right, first, when we're trying to find the limit, the first thing is we put in the numbers and see what happened. First, I put negative 5 in it. Notice negative 5, and then square my 25 over minus 5 plus 5. That gives us 0 over 0. Zero over 0 is indeterminate. Which we can use the Hospital rule. Meaning we'll take the derivative of the top divided by the derivative at the bottom. Notice that we do not use the quotient rule here. Derivative of the top 2x, derivative of the bottom is 1. So pretty much we'll have just limit when x equal to negative 5 of 2x will be negative 10. And that's it. Yeah, make sure it is indeterminate form before we use L'Hopital rule. Right. Next one, if we put in 0, we have cosine of 7 times 0 minus 1 over 0 squared. Cosine of 0 is 1. And so yes, that is also indeterminate. So we use the L'Hopital rule. I'll take derivative of 7x. Just be careful. That will be the chain rule, so I put parentheses around here. Cosine of 7x is negative sine of 7x. And then times derivative of 7x. Just have 7. Kind of like the last one we did here. But this one I use the notation derivative. Here I skip that step and I just go with derivative of it directly. Also, if you want to write the step in the middle, we can also write like this: negative sine of the parentheses, derivative of the parentheses. If you put 7x here, derivative will be just 7. Right. Derivative of 1, that constant will be 0. Derivative x squared will be 2x. So simplifying a little bit, we have limit of x goes to 0, negative 7 sine of 7x over 2x. We do the same thing, put in 0 for x. Negative 7 sine of 7 times 0 divided by 2 times 0 equals 0 over 0. This is also indeterminate. I just put a check mark there. And we use the L'Hopital rule. Which is derivative of this. So will be negative 7. Again, put the parentheses around this. We should have sine is going to be cosine. And then derivative of the parentheses will be 7. Again, I skip that intermediate steps. Over derivative of 2x, 2. Right? 7x. So we will have x goes to 0, negative 49 cosine of 7x over 2. Now that we see there's no x at the bottom, we can put in 0, and that's going to be the answer. Negative 49 cosine of 7 times 0 over 2. Again, we have, just write cosine of 0 is 1 and sine of 0 is 0. Here we have 1. So this is pretty much negative 49 over 2. Right? So, yeah, keep those two values. Right. On the next one, we really don't need to go any further, because as x goes to infinity, only the highest power matters. 0. So here I try to is 0. Something else other than 0 divided by 0, that one is did not exist or undefined. Undefined. And if we have 0 over 0, of course, that is indeterminate. Indeterminate out space. So okay. Infinity divided by something that is not infinity, or we just say finite, is going to be infinity. Something not infinity, meaning finite, divided by infinity will be equal to 0. By the way, when we write infinity, we include plus infinity or minus infinity. And then infinity over infinity is indeterminate. Yeah, out space, sorry, but that's what we have. But as x goes to infinity, only the highest power matters. So I just write that here too. As x goes to plus or minus infinity, the highest power matters in a polynomial or all others. So actually, only highest power term matters. Alright, so we have that. This one I will not finish, but at least we start with. Okay, just keep that for a moment. So right now we only have two forms of indeterminate, 0 over 0 and infinity over infinity. Those two. Here we have another one will be, if we put infinity in it, we have infinity sine of 4 over infinity. Now 4 over infinity, this is what we have is about earlier, a finite divided by infinity will be equal to 0. So we have infinity times sine of 0. Sine of 0 is 0, so infinity times 0. This is also indeterminate. The only thing different on this one is we do not have the quotient form. So we can do that if we write sine of, we can move the x on the top. I just write 4 over x in this form first. This x move to the bottom becomes x to negative 1. So we have limit of x goes to infinity sine of 4x to the negative 1 over x negative 1. And that's pretty much it. Actually, no, it's not it. Now we use the Hopper rule and everything will carry after that. Right. What I do, of course, we can use the Hopper rule and continue. What I do instead is play around with that a little bit. I still have sine of 4 over x Now the x go down, I can write for 1 over x instead. Yeah, x negative 1 or 1 over x is the same. What we can do after this is multiply by 4. So what we have, what I'm trying to get is the 4 that's not what I'm looking for. What we have is those two are the same, and then the 4. It just happened to be there. Now, as x goes to infinity, I should say it. If x goes to infinity, 1 over x goes to 0. Or 4 over x also goes to 0. So we say 4x, I'm sorry. Or we can say this is equivalent to say 4 over x goes to 0 and 4 sine of 4 over x and 4 over x. And we did earlier this equal to 1. I'm not sure about that. Kind of at this step, sine of, or I just want the formula. Limit when x go to 0, sine of x over x is 0. So pretty much that is 1 times 4, so it will be just 4. Or we can use the Hospital rule, take derivative of the top and the bottom, and that's still the same. Right, let me update the list. Now, indefinite integrals. We have a lot here. Right, indefinite integral. So first let's go to the formula. Very important. These are the formulas that you need to know, but this will not be given on the test. So first, that is the power rule. Keep that to do these two problems. And then on the trig rule, we're going to go there whenever we need. You need to know those formula for the test. Right. First, power rule for integral. So first, I will write this as 1 over 7 times t. It is easier this form because now we just do the power rule for t squared, which give us t. You see the formula on that side. The power increased by 1. I only do this for the first problem with the plus 1, and derivative of t is t. Originally is the first power. Now we have 1 plus 1 over 1 plus 1. Right. So that derivative, I'm sorry, antiderivative of t squared and antiderivative of t, or the integral. Now we have 4 and 1 over 7 plus c. That will be just 4 t cubed over 3 plus 1/7 x squared over 2 plus c. That multiply, so we have 4 over 3 t cubed plus 1 over 14 x squared plus c. Right. We did this one in class. As a reminder, I just need to do the first step. We need to rewrite this as integral of y to the 1/2 over 2 plus 4 over y to the 1/2 dy. So it'll be just 1/2 y to the 1/2 plus 4 y to negative 1/2 dy. Alright, we continue from there. I'll let you, actually it is in the note, you can just go and look it up. Next, the trigonometric rule, the formula on that side. First there's sine and the cosine. We just do the cosine of t first. In the formula we have integral cosine of at dt will be equal to 1 over a sine of at plus c. Right, so the cosine of t will be just a, in this case it's just 1, so we just 1 over 1 sine of t, it's pretty much sine of t if we will. So we just have sine of t. Right, and then of course the negative 7 in front of it will stay there. So that's all we have. If we want to make sure, we can always take derivative. If we go back to the original function, we are good, and that's what we have. Right. Next, notice that integral we do not have product rule or quotient rule, so we cannot use the product rule because there's non-existent. What we can do is try to multiply this out, but notice that we can use the trig identities, cotangent, cosine over sine, cosecant 1 over sine, multiply it out, we just have sine and sine cancel, cosine of theta, plus sine and sine cancel, plus 1. So pretty much that's what we have. Now integral cosine, we just did, is a sine. If we take derivative, we go back to cosine, which is good. Derivative of 1, that will go back to the power rule. Derivative of constant, that's derivative of a constant is just a constant times the variable. The variable here is theta, so that's what we have, and always plus the constant c at the end. So that's the integral. Right. So as you see, all of this integral, they have the constant c at the end. For the initial value problem, where we have this condition, something like this condition, we can find that constant c. But first, derivative, if we want to undo the derivative, we'll do the antiderivative. Or the integral undo the derivative. Alright. Now, integrate power rule we apply to this term. X to the negative 3/4 plus 1 over negative 3/4 plus 1 plus a constant c. Negative 3 over 4 plus 1 is 1/4. And that is 1/4 plus c. Divided by 1 over 4 is multiply reciprocal. should give us ax to the 1/4 plus c. Right. Next, we have this condition. We're going to put 1 into x and make that equal to 9. So we have 8 and that must be equal to 9. Yeah, 9 is the values of y and 1 is the values of x. So that's why we have 1 raised to any power is still 1. So we have c equal to 1. 9 minus 8 is 1. Now we can substitute that back into this. So pretty much that. Number 17. I will not finish the problem, but at least get it started. We have velocity and the position. Position function is x of t. Actually, they use s, so let that be s of t. Velocity is the derivative of t. So we have derivative of t is cosine of pi over 2 t. Right. To get back to the function, we need to integrate. Right. And the formula is on that side will be 1 over pi over 2 sine of pi over 2t plus c. Divide fraction is multiply reciprocal. And I give you that part where you're trying to find the constant c. Right. Right. So that is that. Yeah. Next, of course, you need to solve for for c. I'll let you do that part. Right, Riemann sums. The area under the curve using rectangles and the right or the left endpoint. I will look at number 19 here. Right. So pretty much we just have a function, and this is positive, so we're just going to draw. Actually, it will be like this, but just draw something kind of generic. Not going to be exact. We divide from 1 to 5, so 1, 2, 3, 4 and 5, and then we use the left endpoint. So pretty much this we use the rectangles from 1 to 2. Use the left endpoint of 1. Left endpoint of this interval is 1, so that gives us the height. So that's the first rectangle. The height, of course, is the values of the function at 1 times the width is 1. Maybe we should start with the width first. B minus A over N from 1 to 5 divided into 4 equal segment. So the width is 1. Next, from 2 to 3, we use the left endpoint, which is at 2. Find the height, and that gives us a rectangle. The height of this is f of 2, and we just keep doing that. 3 to 4, choose the left endpoint, find the height. That rectangle, of course, that will be f of 3, and then the next one, use the left endpoint. So pretty much if we're going to write that, it will be f of 1, the height, times the width, f of 2, the height, times the width, f of 3 times the width, and f of 4 times the width. Pretty much we have f of 1 plus f of 2, f of 3, and f of 4. Alright. We need a calculator for this. Just put that here. Alright. So first we have the values at 1, 2, 3, and 4. I will store that into a list. So you see above the parentheses there's a curly bracket, and then we have the store and the list. So I open the curly bracket, the numbers 1, 2, 3, and 4. Close that and store into a list 1. Next we have 1 divided by the list square, 1 divided by this 1 square, and we have that. We just need to add all of them up, and the sum is under second stat. Go to math, so second, might write that out. So the sum function, second stat, go to the stat, let's say math, option number 5. And we just hit second answer, and that's what we have. So we're going to add all of this up, and that is 1.426 something. So look like this. So that is, we use the left endpoint. So pretty much we find the width of each interval, and then find the height, the values of the function, multiply the height and the width. We have one area of one rectangle. Add all of them up, we have it. right? I'm going to pause the video for a few minutes, and then we'll continue in a few minutes. And we are back. Alright, next we do use geometry to find sketch here. So first, I have the function is x. When x equal to 2, y equal to 2, and when x equal to 6, y equal to 6. Pretty much we have that. Looking for a ruler here. So we have that. This is the function f of x equal to 6. We want to find the integral from 2 to 6 of, I don't know why I write 6, but this is x. Right. So this integral we calculate the area under the function from 2 to 6. Pretty much this area. Right. So we can divide this into two parts. The first one, the rectangle. 4 by 2. So the area here is 8. Next, this area, the length is 4 and 4. So 1/2 base times height. 1/2 base times height will be 8. Also, and the area, both of them above the x-axis. So add all of this up, and that will be 16. And that will be the integral from 2 to 6. Right, simple enough. This just happened to be positive, so it's good. Next, absolute values of x. If we're going to draw it, it will be like this. And we want to go from 1 to 5. So pretty much this. So the area here and -1. So pretty much we find the area of those two, add up, and that's it. I'll let you do that. Notice that both of these are above the x-axis, so we just add them up. If one of them below the x-axis or both of them below the x-axis, we need to take whatever above plus the one at the bottom will carry the negative sign. So we see that here on number 22. I leave that part for you. So two triangles, pretty much. Now, again, area cannot be negative and the integral can be negative. So in this question, we are asked to find the integral from A to C. We have the area of 5. So if we want to add them, it will carry the negative sign. and the 4 is above the x-axis, we carry the positive sign. So whatever below, we carry the negative sign. Whatever above will be positive. And that makes sense because if we have to use the Riemann sum, this one, the height is going to be negative. The function value is going to be negative and end up being negative. Alright, so that's pretty much it. -1. So we already have 20 here. Next we have properties of definite integral. Right. So first we have the integral from 3 to 7 of the function f of x, and then 3 to 7 of g of x. The limits are the same, and we have the linear combination. So pretty much what we will do, we can split and then the constant we can bring in front. And the rest is simple. The integral of f of x is -2 and g of x is 9. So we have 4 times -2 plus 9, that is 1. Right, so we have two different functions and we do the linear combination of it. Next, we have the same function, different limits, so we have to play with the limit here. So what we are given is integral from -1 to 2 and integral from 2 to 9. We asked to find integral from -1 to 9. So we write integral of -1 to 9 of h of t dt Right, so since we go from -1 to 9, we can stop at any number. I'm going to write like this first. We can go from -1 to 9. We can stop at any number we want. Here we stop at 2. And then start at 2. So instead of go from -1 straight to 9, we go from -1 to 2 first, and then from 2 to 9. Right, so that gives us -1 to 2 is 2, 2 to 9 is -8, is 6. So from -1 to 9, we have 6. Next, what we do is, instead of -1 to 9, it is 9 to -1. So if we interchange the limits, we're going to throw in the negative. And that is just, sorry, this is -6. So -6 is +6. So 2 plus -8 is -6, and this is +6. By the way, that one is too easy. I think we need to do something a little more challenging. Consider this. Let's say we will have the limit of the function from 0 to 3 of dx. I just make it up 5. And let's see is 8. The question is, what is the limit from 3 to 5? So that is what given. We need to find this. So given that, find this one. Right. So what we do is we're going to split the limit. Instead of go from 3 to 5, we know we end up at 5. We can stop at any number in the middle. We choose 0 because in the problem we are given the other than the number 3 and 5, we are given 0, so we have to use it. So that makes sense. So we go with 0, and then that's what we have. Now we are given 0 to 5, so this is 8. That part is easy. We're not given 3 to 0, we are given 0 to 3. So again, interchange the limit, throw in the negative sign. And 0 to 3 is 5, but with the minus. And 0 to 5 is 8. So this is going to be 3. So this is more like it. We just look for the integral. This integral, instead of going straight from 3 to 5, we just go to 3 to 0, and then from 0 to 5. Both integral process that. Right. Next we have the area of the shaded area. So we have the function y 4 minus x squared will be this. If it's not clear, this point is 2, because when x equal to 2, y equal to 0. So pretty much what we ask to find here is the area. Notice that this time we find the area and not the integral. By the way, number 25, it's not going to be on the test. I'm going to do that in class. So that's why we kind of skip that. Right, the area. Notice that this is the area. So if we want to, we have to split. If we do this part here, so that in blue, this area will be the same as the integral of 4 minus x squared dx. That goes from 0 to 2, because that is 0 to 2. And then this area will be equal to from 2 to 3 of 4 minus x squared dx. So pretty much we just have the function and then the limit, except the important things here is that this one is negative because it is below the x-axis. This one is above. So we just do 2 in integral. And we have it. By the way, if we just ask to find the area like this, we can use the calculator. So let's bring the calculator again. Right. So we'll go to math. Option number 9, I think, will be this. It goes from 0 to 2. The function is 4 minus x squared. And we have that. Always can Sometimes you can convert to a fraction. So this will give us 16/3. Next, we have negative of the integral that go from 2 to 3 of 4 minus x squared dx, and that is convert to fraction is again 7/3. Notice that it is area, to make perfect sense if both of them are positive. So the total area, we just add them up, will be 23/3. Yeah. So if we have the area, the integral, we have to be careful with the plus or minus. Right. If I ask for the area, you definitely can just use the calculator. If we ask you to evaluate this is the fundamental theorem of calculus. We have to do this by hand. I will check the work by hand. So this one, the calculator is okay. 26. But the definite integral here, that is the fundamental theorem of calculus. I just said, most importantly here is no calculator. Right. Right. Sorry, I hit pause again. I need to check a few things. Right. Fundamental theorem calculus. So this is very important. It is definite integral is f of a minus f of b minus f of a. So the upper limit minus the lower limit. Right. So now let's see how it works. First, 0 to 9, we can rewrite this as x to the 1/2. Integral x to 3/2 times 3 divided by 3/2. Notice that this one we do not have the constant c. So sometimes we just write f of x that go from a to b. So we do the same thing here. That will go from 0 to 9. Right. So 9 multiply reciprocal 2/3 x to the 3/2, 0 to 9. Of course, you can put 9 and 0 here already, but let's first simplify this. 5 and 2/3 is 10/3. X to the 3/2, we can write x cubed, and then the square root. X to 3/2 is square root of x cubed. Right. And then we go from 0 to 9. So we put 9 in. And then where we put 0 in for x. So that gives us square root of 9 cubed. We can also do this. 9 to the 3 half. 9 is 3 square, 3 half, 2 and 2 cancel, 3 cubed. So that will be 27. So we have 10 over 3 times 27 minus this will be 0 because 0 any power is still 0. So 27 and 9, so cancel out, we're going to have 90. Alright, so the point here, we just integrate, find any antiderivative. There's no constant c, but instead we have the limits. Evaluate at the upper limit, subtract where we have the lower limits. Right, 28. This one, there's no chain rule, no product rule, no quotient rule, nothing. What we can do is just have to multiply this out. T times t, t squared, t times 1 plus t, that is 1. And 1 times t plus t, also 1. 1 over t times 1 over t. So pretty much that. Which becomes t squared plus 2 plus dt. We can write as t to the negative 2 for 1 over t squared. Right. Next, we just integrate 1 over 3, t cubed over 3. That for t squared. For 2, constant, stick a t to it. Now we're on the power rule. Yeah, the power rule is over there. And then t to negative 2, we have t to the negative 1 over negative 1. Increase the power by 1, divide by the same thing. That goes from 1 to 2. Alright, so clear this out. Move this down, we have actually minus 1 t to negative 1, move to the bottom, become t. Need to have something on the top to hold the place, and that is 1. Right, so pretty much this. Yeah, we do by hand up to that point. The rest we can use the calculator to check. So now we have the function at 1 and then the function at 3. So first, just store 1 into x, and then we enter the function x cubed divided by 3 plus 2x minus 1 over x. We can change the fraction for third. So we're going to put 2 in there and then put 1 in there. I'll just do this. 2 cubed over 3 plus 2 times 2 minus 1 over 2. And then we're going to put 1 in it. 1 cubed over 3, 2 times 1 plus 1 over 1. Right, the first one we have is 4/3. And now we just let 1 store into x. And then we'll go up there. Hit enter. So that will be copy and paste. So with that. Let's do that again. Oh, sorry, we have okay, first 2 store into x. We have the 2 first, and then we evaluate the function. Alright, much better, sorry. 37/6. And when x equal to 1 store into x, and evaluate that function. That is 4 terms. Yeah, the upper limit minus the function at the upper limit minus the function at the lower limit. So we can also do this. We have that, subtract that. 29/6. Yeah. So that part you can use a calculator, but all of this part when you integrate, I need to know that you know how to do it. Next we'll go to 30. 29 kind of simple. Right. Integral for cosecant square. For cosecant square, which is this. So integral of cosecant square is cotangent, negative cotangent square. Pi/4, 3 pi/4. Alright, so we have -5 cotangent of x, go from pi/4 to 3 pi/4. So put the upper limit, subtract where we put the lower limit. Right. Now just evaluate this. -5 cotangent is cosine over sine. Minus that plus 5 cotangent is cosine over sine. Right, first -5. Cosine 3 pi/4. That gives us negative. So we have 2/2. Sine 3 pi/4 is positive. And then plus 5. Cosine pi/4 and pi/4, both of them the same thing. So we have 2/2. So we have pretty much that cancel, give us 5 plus 5 will be 10. So other than the trig function, we just need to integrate cosecant square, give us cotangent. Again, this formula you need to know. Right. So what we did was 27 and 28 and 30. You can use the calculator, but need to integrate. Yeah, that is more precise statement. Right. The last part is the other fundamental theorem of calculus. So I'm going to write this form. You see this in class. Derivative of the integral that have let's write g of t to h of t. Sorry, this is x. G of x, h of x of the function t dt. Both of them x. Derivative of integral. What we do is we're going to just put h of x in here into t, but then have to multiply by the derivative of it, and then minus where we put in the lower limit, and have to have the derivative of the lower limit. Note that we have to have this. Now let's take a look at 32. So what we do is, first thing we're going to substitute in 0 in square root of t. And then multiply by the derivative of 0. Derivative of a constant is equal to 0, so that's why this one goes to 0. Derivative of a constant is 0. Next, subtract. Now we're going to put x to the 6 into t. And then we have to have derivative of that. So that is 0, so we have negative cosine. Square root of x to the 6 will be absolute values of x cubed. The reason behind this is absolute values, square root of a square is absolute values. So if we have x to the 6 will be x cubed square, give us x cubed, which is the same as x cubed. But I think it's better to write x cubed with the absolute values inside, the cube inside absolute value. And derivative of this is 6x to the 5th. Derivative of x to the 6 is 6x to the 5th. Right, I'll write that in front. And then cosine of, I said it is better to write the cube inside absolute values. The reason that the answer in the back it doesn't have the absolute values, simply because cosine is an even function. So whereas plus or minus, it doesn't really matter. So in here I should say it could be equal to plus or minus x cubed. But plus or minus doesn't affect the cosine. Cosine is an even function. So that's what's good. Right, so that is 32. Just do 31 as well. 31. So first substituting the square root of x into it. We have 16 square root of x to the 9 power. And then derivative of square root of x. That's the upper limit. Substitute the low limit for t, 16, 1 to the 9, and then derivative of 1. Derivative of 1 is a constant. Still using that form. Derivative of 1 is a constant, so that's equal to 0. We just have this. So 16x. Right, we can write like this. Square root of x is x to the 1/2 to the 9 power. Derivative of square root of x, we did many of this. 1/2 x to the negative 1/2. Right, now once we multiply everything, just simplify the exponents. 1/2 times 9 give us 9/2 times 1/2 x to the negative 1/2. when we multiply two things with the same basis of x, combine the exponent 9/2 minus 1/2, we have x to the 9/2 plus negative 1/2 will be a over 2 will be 4. 16 times 1/2 is 8. So that's what we have. Right. So pretty much what we have here is called the Leibniz theorem. G of x to h of x. Put in the limit, but have to take derivative. When we have the derivative of the integral, have to have the derivative though in order to do that. Right. So with that we finish everything that is required that we will need to know for test 3. I hope you find this helpful. Thank you for watching.